So when looking at the female pelvis and kind of getting our orientation, then this is the bladder. This is the vagina we're seeing. So this is a uterus that's sitting on top of the bladder, and then here's the rectum that we're seeing posterior to that. So when we're looking at the uterus itself, the front of the uterus, which typically points anterior, is the fundus of the uterus. This portion of the uterus, this broad portion of the uterus, is the body of the uterus. And then this portion that begins to taper here is the isthmus of the uterus. Now, if we open the uterus up so we can actually see it, then the space where the baby would develop in the uterus is called the uterine cavity. The termination of the uterus in the vagina is called the cervix. And so what we have is an opening at the end of the cervix we call the external os. We have a little canal that runs through the cervix called the cervical canal. Then we have an opening into the uterine cavity itself right here, which is the internal os. And so external os, cervical canal, and internal os are the parts of that. Now, the uterus itself has to be kept in place because it's got a lot of pressure on it, particularly when it's carrying a baby. So we have a very, very broad ligament that comes off laterally of the uterus that we're seeing here, which is called the broad ligament of the uterus. Anterior, we have a ligament that comes off that we can see right here, coming off the fundus where the fallopian tube enters and goes exactly to the same location where the inguinal canal is in men, which is called the round ligament of the uterus. And then posterior, we have a ligament that we can see in here that runs off of the isthmus of the uterus up to the sacrum, so the uterosacral ligament. So we have the broad ligament, we have the round ligament, and we have the uterosacral ligament that we can see here. Now, if we cut the uterus open, then what we're going to see is that it's got a pattern similar to the heart. It's covered by material on the outside. It's got a muscular mass, and then it's got a lining to the inside. So what we can do with the uterus is call the outside material of the uterus the perimetrium, the muscular wall of the uterus the myometrium, and the internal lining of the uterus the endometrium. So what happens on a monthly basis is this inner tissue, the endometrium, thickens post-ovulation, pre-ovulation, and then post-ovulation continues for implantation. If implantation doesn't occur when progesterone levels drop, then all of this inner lining sloughs off, and that's what's part of the blood flow or menses that occurs when a woman's on her period. And then you start that same process over again the next month. So when we're looking at the tube that connects the ovary to the uterus, it's called a fallopian tube. And the egg is ovulated out here in the abdominal cavity. And little finger-like projections off the end of the fallopian tube here are responsible for collecting the egg. So these are called the fimbriae of the fallopian tube. And then this enlargement at the end of the fallopian tube here is called the ampulla of the fallopian tube. And so as we move forward into the fallopian tube, we get into the isthmus of the fallopian tube here. Now in humans, the fallopian tube is not designed for implantation, so we get an implantation event that's called an ectopic pregnancy. But in cats and dogs that have a number of babies, they aren't in the uteral lining, but they line up in the fallopian tube as well. So again, we have the little fimbriae associated with the infundibulum of the fallopian tube. We run into the ampulla of the fallopian tube, and eventually the isthmus of the fallopian tube as it attaches to the uterus itself. So breasts are part of the reproductive system in women, designed to produce milk to nourish babies. So I think the anatomy that most people are fairly aware of is the nipple at the end of the breast and a darkened area of thickened epithelium around it that we call the areola. Now, the two breasts you're looking at are supposed to be designed to represent the breasts from the same woman, but this is a non-pregnant breast, and this is a lactating or pregnant breast. So when we open the breast up, then what we have is we have ligaments that come from the upper part of the breast and come down to the top of the nipple area and support the breast. So those are called suspensory ligaments or Cooper's ligaments. And they get stretched with time so that the breast changes its height from what we were seeing in this breast to a breast that is more pendulous that we're seeing in this breast. And so what happens is when you're not pregnant, most of the breast is adipose tissue. And you have this rudimentary lactiferous tissue that will eventually allow you to make milk. As a side note, men have this same tissue in their breast. And so men can get breast cancer just like women because we have this rudimentary lactiferous tissue. So when a woman becomes pregnant, a hormone released from the anterior pituitary called prolactin and followed along with progesterone are responsible, and estrogen are responsible for preparing the breast. So progesterone and estrogen cause this tissue to greatly enlarge. So that if we compare this non-pregnant breast to this pregnant breast, you can see that now the breast is dominated by this lactiferous tissue that's greatly increased in size under the guidance of progesterone and estrogen. At the birthing process, we get a peak in prolactin, and it actually causes milk production to occur. So progesterone prepares the breasts for lactation, and prolactin actually causes milk production to occur. So what we can do is we can divide the breast into lobules. So each one of these is a lobule, and the cells associated with it that will begin to produce milk are called acinar cells and acini. So they're alveoli, clusters like we saw in the lungs. The duct that drains each lobe used to be referred to as a mammary duct, but some books have now changed that name to a lactiferous duct. When we get just behind the nipple, we have an enlargement of those ducts that are referred to as lactiferous sinuses. They actually store milk so that when baby first starts nursing, they get some milk before milk letdown occurs. And then it varies in mammals, and some mammals only have one duct that exits through the nipple. Women have a number of little ducts that exit through the nipple. So each lobule is drained through the nipple by its own duct, which is called a lactiferous duct. So what I do is I retain the old terminology because it helps us make sense out of it. So this would be a mammary duct draining a lobule. These are lactiferous sinuses just behind the nipple. And then these are the lactiferous ducts that pass through the nipple and then allow the milk to get to the outside. And so a mammary gland is all of this tissue designed to produce milk, whereas a breast is a reference to the mammary gland tissue and the adipose tissue that's associated with it.